Hello and welcome to this tutorial on numeric data types in Python. In this video, we will cover the basics of numeric data types in Python and how they can be used in programming. First, let's understand what are numeric data types. In Python, numeric data types are used to represent numbers in a program. There are three basic numeric data types in Python: integer, float, and complex. Let's start off by looking at integer data types. Integers are whole numbers without decimal points. Let's see an example of working with integers. So here we define two integer variables, num1 with value 10 and num2 with value -5. We then perform addition using the plus operator and store the result in the sum variable. Finally, we print the sum using a formatted string using the print function, which gives us an output of 5. Let's talk about float data types now. Floats are numbers with decimal points. They are useful for representing fractional or decimal values. Let's see how they work. So let's go through what we are doing here. Here, we declare a float variable pi to store the value of pi. Some would call it p or pi, but anyways. We also define a variable radius representing the radius of a circle. Using the formula for the area of a circle, we calculate the area and store it in the area variable. Finally, we print the area using a formatted string. So if we run this now, we should get the result as 19 something roughly. Now let's move to the complex data types. Complex numbers are used to represent numbers with both real and imaginary parts. Let's take a look. In this example, we create two complex number variables, complex underscore num1 and complex underscore num2, using the complex function with some values. We then perform addition using the plus operator and store the result in the result variable. Finally, we print the sum using a formatted string. Hence, we get the output here to be 6 plus 2j. Let's go through numeric conversions now. Python provides functions to convert between different numeric types. Let's see how that's done. Let's go through the code here and see what's happening here. So we have an integer variable num with the value 10. We use the float function to convert it into a float and store the result in float underscore num. Similarly, we convert it to a string using the str function and store it in string underscore num. Finally, we print the converted values using formatted strings. We can do two more examples now and try something different before we finish off this lesson. Let's explore a few more scenarios to solidify our understanding of numeric data types. First, let's create a little program to demonstrate the use of the modulus operator in Python. The modulus operator, represented by the percentage symbol, calculates the remainder when one number is divided by another. Let me show you how. Let's see what's going on here. So we first define two variables, num1 and num2, and assign them the values 17 and 5. The modulus operator calculates the remainder when num1 is divided by num2. The result is assigned to the variable remainder. Finally, we print a message that displays the values of num1, num2, and remainder using a formatted string. This provides a clear and informative output statement which indicates that when 17 is divided by 5, the remainder is 2. Okay, let's close off our lesson with this last example and the purpose of this example is going to be to showcase how to calculate exponentiation in Python using the asterisk asterisk operator. What we are doing here is first declaring two variables. The variable base is set to 2, representing the base number. The variable power is set to 3, representing the power to which the base number will be raised. The exponentiation operator asterisk asterisk is used to raise base to the power of power. The result of the exponentiation is stored in the variable result. Finally, a message is printed to the console, displaying the base number, the power, and the calculated result. So if we run this now, it should show us what the number will be if we raise 2 to the power of 3. This can be useful in various mathematical and computational tasks, such as calculating compound interest, exponential growth, or performing complex calculations in scientific or engineering applications. That's all about numeric data types in Python. We have covered the 3 basic numeric data types: integer, float, and complex, numeric operations, and type conversion. I hope this video has been helpful in understanding the basics of numeric data types in Python. Let's catch up in the next lesson.